All right, so today we're going to finish up our last section in 10.6. It's on equations of circles. There won't be any theorems today that we have to learn about chords and things. All we're going to do is learn how do you write the equation of a circle and how do you graph it. Okay, that's pretty much it. Okay, so there's two things that you need to know to write the equation of a circle in the coordinate plane. What are the two things, and I kind of just said them earlier, but what are the two things you think you need to know about the circle? You got to know the radius. That tells you the size of it.
And where it's located.
And where it's located. Specifically, there's one point you need to know, and that's the center. Right? So if you want to write the equation of a circle, you have to know the radius, and you have to know its center. The equation that we're going to use is for the radius. So if they give you the diameter of a circle, that'd be a little tricky. First thing you got to do is remember, oh, they gave me a diameter. He said I really need to use the radius, so you got to cut it in half. Okay? So make sure you always use the radius. Okay, so I'll give people a second to copy that down. All right, so suppose we're going to let the radius of the circle be represented by r, and we'll let the coordinates of the center of the circle be h and k. R, h, and k will all be numbers in a real problem. Okay. We're going to let x, y just be any point on the edge of the circle, any point on the circumference. We're going to use the distance formula to figure out what is the equation of a circle. Does everybody have the first paragraph? Okay. Right, so here's the picture we're going to use to figure out the equation of the circle. Okay, and what I want to do is try to use the distance formula to find the length of the radius. That's all I'm going to do. I'm going to use the distance formula to find the length of the radius. And that's going to tell me the equation of the circle. Anybody remember how you use the distance formula to find the length of a segment? Remember? Anyone remember anything about that, the distance formula at all? It's based on the Pythagorean Theorem.
X squared plus y squared equals c squared.
Not quite. All right, let's just go back and go over the distance formula. So you did the distance formula in Algebra 1. Okay, we reviewed it at some point in this class, probably back in, I don't remember, an earlier chapter. Set up 2 points. Nope, not slope. So we're going to have a point here. Let's call that point
x1,
y1. Okay, we'll have another point. Call it x2, y2.
yeah, into x1 minus.
You remember that?
x2 minus x1 over y1, 2 minus y1.
Kind of. That's the slope flipped, but. All right, let's keep going. Let's look at this. All right, so we've got our segment, and I want to find the length of it. Okay. In a second, we'll go back to the circle. what shape could I make out of this segment that would make this a hypotenuse?
Triangle.
Triangle. Right? So basically, if I can find the length of the bottom side, and I can find the length of the height, I can use the Pythagorean theorem, because I'll know two sides to find the third. Okay? So start with the bottom. What's the x-coordinate of that point? Yeah?
X2.
It's at x2. Okay. What's the x-coordinate of that point? Yeah?
X1.
X1. Okay. So you know where this one starts, you know where this one stops. How would you find the length if you know where something starts and stops? You had the two numbers. It's like you're looking for the change between x2 and x1. How far over did you go? It's kind of like if I said in the morning the temperature was 40 degrees, in the afternoon it went all the way up to 70 degrees. What would I do with those two numbers to find the change in the length?
X2 minus X1.
Yeah, I do x2 minus x1. Okay? That's the length of the bottom side. Okay? Now the height, well, the first y value here is at y2. Second y value is y1. You do the same thing. You'd subtract them. If you know where you started, you know where you stopped, take the two values and subtract, you can find the length. Now you've got two lengths. So in the Pythagorean theorem, take one leg, square it, take the other leg, square it, add them up, and that would be equal to the hypotenuse. We could just call this h for hypotenuse. Hypotenuse squared. One side squared plus the other side squared equals the hypotenuse squared. That's your distance formula. Okay. So now we're going to do the same thing, and it's almost going to look exactly like that, except different letters. Okay, it is. It's going to look exactly like that. Okay, well, let's go back to the letters we have. So now I want to find the length of that radius. Okay. Well, since we're going to use the Pythagorean theorem to do it, we're going to get the length of the radius squared. What would be my first part? What would I put in the first parentheses? Again, think of this as your first x value. Think of this as your second x value. And what you would do with this, something, and then that. Yep.
H minus X.
So we could write it that way, but let's write it x minus h. Right? Just because x is a bigger number in this case, it's further to the right, and we'll do minus h. I think we might have done it the other way when we looked at the formula. It doesn't really matter which way you do it, because when you square something, it's going to handle, if you had a negative, it would get rid of it. Okay? That's the only difference when you change the order you subtract. You could get a negative. But if you square it, it's going to get rid of the negative anyway. Okay, but let's just get used to writing it as x minus h. And what about in the second set of parentheses? Well, Kiara, what would I have here?
Y minus k.
Yeah, y minus k. This is the equation of a circle, where you have your center at coordinates hk, and your radius is r. So this is the equation of a circle. When you write a final answer on a test, you're going to fill in for three letters. You're going to fill in for r, you're going to fill in for h, you're going to fill in for k. I'll put a box on everything you'd fill in for. Never fill in for x and y. Just like when you write an equation in slope-intercept form. You fill in for every letter you see there except x and y. So you might have an answer like y equals 2x plus 3. But you'd never fill in the x and the y. Same idea. Okay. What's going to happen if my circle is centered at the origin? What would happen there? H would be 0 and k would be 0. So it basically would become x minus 0. You don't even need to write that. It would just become x squared. And it would become y minus 0. Again, you don't need to write y minus 0. It would just become y squared. Right? So in the case when it's at the origin, the h and the k disappear. Okay? All right, so let's try an example. Okay, you guys already wrote that down. Okay, that's the standard equation for a circle. Radius r, center hk. Okay, we did it on the other page. Okay, so what I want to do is write the standard equation of a circle with the center negative 4, 0, and the radius 7.1. Okay, when I write the equation, what are the 3 letters I need to know? About Dakota. What are the 3 letters I need to know? So we put blue boxes around them on the other page. Okay, tell me the characteristics of a circle you need to describe to write its equation. Forget the letters. What are the 2 things you need to know about a circle to describe its equation? Okay, you got to know the size of the circle. You got to have its radius. And what letter was the radius? R. Okay, there's 1 letter you need out of the 3. And besides the size of the circle, you need to know what else? The coordinates of the center. Remember the 2 letters we used for the coordinates of the center? Anyone help them out? What are those 2 letters, Sarah? H and K. Which one is negative 4, Sarah? H and then K. It's alphabetical order. H comes before K. All right. So now we know our 3 letters. Now write down your formula. Fill in those 3 numbers where they go. X minus h squared plus y minus k squared equals 7.1. All right, so we have x minus, now look at h. H is negative 4. Be careful when you have these 2 minuses together. One of the minuses comes from the formula. The other is a negative coming from the number. Okay? We'll talk about that in 1 second. Now you have y minus k. K is 0. Equals, oops, sorry, I meant to write r squared. Now I'm going to plug in r. Okay, what can I do in this first set of parentheses? Yeah, change it to x plus 4. Right? Instead of writing it as minus a minus, write it as plus. Okay. How about the second set of parentheses? What's going to happen there? I'm just going to have y squared. There's no reason to write minus 0. And then the last part, just take 7.1 and square it. 50.41. Okay, there's the equation of a circle that has a center at negative 4, 0, and the radius is 7.1 units. Any question on that? Now, what if I gave you this equation, and I said to you, just looking at this equation, tell me the radius of the circle. How would you figure that out? If I said, okay, here's my equation of my circle, tell me the radius. Yep.
Square root 50.
Yeah. That last part, that's the radius squared. So if you wanted to know what the radius was, you could take the square root of that last number, work backwards, and figure out how big the circle is. You can also work backwards and figure out the center. Okay? Well, k would be easy to find. I'd know it's 0 because there's no number next to y. You'd have to be careful with h because of this step right here. We had minus a minus and we changed it to a plus. All right? So you got to be careful when you figure out h and k looking at the equation. Okay? The way I figure it out is I say, what number comes after the minus sign? Okay? What number comes after the minus sign? That's your h and that's your k. Okay? If you see a plus sign, well, you got to rewrite it. You got to think of it this way. Think of it the way it was originally. It became plus because it was minus a minus. What number comes after the minus sign? -4. That's my h. What comes after the minus sign? 0. That's my k. All right, so we'll practice working backwards a little bit. But that's, some people get a little tripped up. They accidentally write 4 instead of -4 for h. It happens a lot. All right, so this one, it says we've got the point 1, 2 is on the circle, and the center is 5, -1. What am I missing? I'm missing something that I really need. Yeah? I don't have the radius. They didn't give it to me. Okay. They gave me h. They gave me k, but I don't know r. So here's your center. It's at 5, -1. And the point 1, 2. This is not to scale. The point 1, 2 is on the circle. How can you get your radius? Yeah. Yeah, just find the distance. Okay? The distance between those 2 points, that's your radius. Okay, so let's start out by finding your radius. Anytime I use the distance formula, I always start out by doing this. Then just fill in all 4 spots. All right, so you're going to have 1 minus 5, 2 minus -1.
Could you just put +1?
Yeah, that's just going to become a +1. So let's do that out. 1 minus 5, bless you. 1 minus 5 is -4. What's -4 squared?
16.
16. Good. Okay, next, as Luke just said, minus -1 becomes +1. 2 plus 1 is 3. 3 squared is 9. What's 16 plus 9? 25. And what's the square root of 25? 5. Okay. So I'll write it on a separate line for you. So I've got r squared equals, you know what? Since I put the square root on the other side, I already took care of the r squared. If you don't put the square root on the other side, you're going to have to take the square root as the last step. Okay? But that's how I like to do it. I like to just say, you know what? I'll just go like this right now, so then I can get rid of that. If you don't want to do it that way, do it that way. Okay, so my radius here is 5. Okay, now I've got h, I've got k, I've got r. Okay, anyone think they can tell me the equation of the circle? What do we start out with?
5. Right. Is it 5 squared equals?
Okay, yep. So you're starting with that. That's fine. So r squared equals
H, which is 5.
Let's just go back and take a look at that equation one more time.
Oh. X minus 5.
There we go. So we got x minus 5. And what do we do with that?
Square it.
We square it. Plus Good. He said y minus negative 1. That's perfect. We're going to just fix that in a second. So we're basically done except for doing out 5 squared and fixing y minus negative 1. Jacob, 5 squared gives me how much? 25. This is fine. What about this second part? What should I make that? Ariel? Y plus 1 squared. And that's the equation of my circle with a radius of 5 and a center at 5, negative 1. Okay, so a little bit harder than the last one because you had to use the distance formula to find the radius yourself. Okay, any question on that one? Okay, let's let me just make one up, and I want you to tell me the center and the radius. So I've got 9 equals x minus 2 squared plus y plus 8 squared. Okay, let's start with the radius. Okay, that's a little bit quicker to find. What's the radius of this circle?
No.
3. Okay. Radius is 3. What's my center? Okay, and B, you got to be careful here. My trick, again, for you, look at the number that comes after the minus sign. Morgan? Perfect. 2, negative 8. Number that comes after the minus sign with x, that's h. Number that comes after the minus sign, I don't have a minus sign. So think of it this way. Negative 8 would come after the minus sign. Okay? 2, negative 8. Again, the mistake a lot of people make is they write 2, 8 for the center. They forget the negative on the 8. Okay? All right, so next one we'll look at is a graph. Okay? As long as you know the equation, you know how big to make the circle, you know where to put it, you can sketch it. And what we just did in the last problem, that's the first thing I would do to sketch a circle. Write down your center so you can mark it. Write down your radius. Okay. James, what's my center here?
2,
What is it?
2, 3.
No. That's the mistake, the common mistake people make. I like the 3. The 3's good, but not the 2. What number comes after the minus sign? Negative 2. Okay? So you have to think of this as x minus negative 2. That's what it would have been originally. Okay? Negative 2, 3. Any question on how to get the center? Okay, good. What's my radius? Jacob? 3. What do you think the mistake some people say the radius is?
9.
They say 9. Okay, that's the radius squared. You got to remember to take the square root of it. Okay, so mark your center. Left 2, up 3. Now, the easiest way to draw a circle with a radius of 3 is just count 3 units in every direction, up, down, left, and right, and then make your circle if you don't have a protractor. So go 3 units right, 3 units up, 3 units left, 3 units down. That'll give you kind of an idea of how to sketch your circle. But I'm just going to kind of cheat.
Oh!
It's pretty good, huh? All right. So there's your sketch. Okay, if you want to look at my sketch and copy down maybe a couple other points that it looks like it goes through, you could grab those and it might help make your sketch a little better.
You end up watching this video so the guy's like,
No, I have to look at that.
That's really cool.
Okay, and that's it. That's all there is to graphing a circle. Just make sure you get the center and the radius correct. Okay. Any question on that one? Okay, so don't throw away the graph paper. We're not going to use it for the next problem we do in class. I don't think we'll use it, but you will need it for the homework. Okay, so this is example 4 on page 637. Okay. They give you a diagram, but basically what's happening here is they've got some lights, okay, on stage, and each light illuminates a circular area on the stage. Okay, so like if you look at it from up above, the stage would be lit in a circle. Okay. A coordinate plane is used to arrange the lights. All right, so we've got this light on stage. Okay, a coordinate plane is used to arrange the lights. And they put the corner of the stage at the origin. That just makes the math a little easier. Okay, this represents one of the lights, this equation. So the radius represents the size, how much of the area, how much of the stage is lit up, and where on the stage it's lit up. Okay, so we got a picture. First thing they want us to do is graph this disk of light. So basically, here's our stage. We're going to graph the part of the stage that's illuminated, okay, by the light. Okay, let's start with where the light is on the stage, okay, the center of the light. All right, so let's get our center. Anyone tell me on the stage, where is the center of that light? Yep. It's at the coordinates 13, 4. Okay, here's the corner of your stage right here at the origin. Okay, the center of the light is 13, 4. Wouldn't make sense to have negatives in this case. Negatives would be off the stage. Okay, positive, positive. Okay, so there's my center. What's my radius? Yep, 4. So this light basically is going to illuminate a circle of a diameter of 8 at the center 13, 4. So if you're graphing this on your grid, you can just watch me graph it. But if you want to graph it, you're going to have to go by 2s. Okay, you have to go by 2s. So let's go over 13. And then up 4. Okay, that's the center of the light. And it's going to shine out 4 units in each direction. Okay, since I'm going to use my circle tool, that's all I need. Okay, that's the area of the stage that's lit up. Okay, any question on that? Okay, in fact, what I'll do is I'll color that in yellow. Okay, so we know that's the part that's lit up. There we go. Okay, so anybody that's standing in that area, they're going to be lit up. And I think that's what they're going to ask us. They're going to give us the coordinates of where someone's standing and ask if they're in the light. Okay, so 3 actors are in the following locations. Which actors are going to be lit up? Okay, Henry, 11, 4. Is Henry going to be lit up? Yep. Okay, Jolene, 8, 5. 5, 6, 7, 8. Jolene, is she going to be lit up? No, she's outside the light. Okay, Martin, 15, 5. So we got 10, 11, 12, 13. Okay, if I counted correct, hopefully I did 15, 5. Is Martin going to be in the light? Yep, so he's going to be in the light. All right, so all that problem really had you do is graph a circle. Make sure you put it in the right spot so you can figure out which actors are inside the circle and which ones are outside. That's basically the whole problem. Okay. Any question on that? Okay, everybody feel comfortable, or does anybody have any questions about if I give you an equation, how you can figure out the center and the radius? Okay. What's the trick I said to use? To look for the center, you look for the number that what? Yep. After the minus sign. Perfect. Look for the number that comes after the minus sign. And that will be the coordinates of your center. Okay? How about the number at the end? What do you do to that to turn it into the radius? Take what of it? Take the square root of it. Okay? Just make sure we remember the letters. What's the first letter that goes with x? H. Okay. What's the letter that goes with y?
K.
K. And the radius, we represent that by r. Okay, last thing, let's just make sure everybody has, what's the equation of a circle with all letters? What's the standard form?
R squared
Yep, r squared.
equals parentheses x minus h squared
Yep,
plus y minus k squared.
good. That's the standard equation of a circle. What happens if either h or k becomes 0?
Then it's just x by itself or y by itself.
Right, if h is 0, you're just going to get x by itself squared. If k is 0, you get y by itself squared. It simplifies a little bit. Okay? Okay, so that's everything you need to know about circles. Right, so the homework, it's on 638. Okay, keep your graph paper. You will need it for a couple problems. 3 to 15 all, 19 to 31 odd, 33 to 36 all, and 42. Okay, we'll go over that tomorrow. And don't forget, we have our test tomorrow on sections 10.3 to 10.6. And I'll be after school today for a little bit if anyone needs extra help.